Hello everyone, welcome to BakoMaths, and to this lesson we are going to look at differentiation of a quotient, where we will emphasize on the quotient rule. And if you have not subscribed to this channel, kindly subscribe and hit on the notification bell for more updates. Now let's start. So quotient rule. The quotient rule says that if y is equal to uv, where u is a function of x and v is a function of x, then dy dx is equal to v du dx minus u dv dx, all divided by v squared. And so when we want to differentiate two functions being divided, we can apply the quotient rule, which says that dy dx is equal to v du dx minus u dv dx, all divided by v squared. So let's look at practical examples where we can apply the quotient rule. So example 1 says that we should differentiate y is equal to 3x divided by 1 plus x squared with respect to x. And so look at the function, we can see that these are two functions being divided, and so to differentiate we apply the quotient rule. So we have our solution here, and the function is y is equal to 3x divided by 1 plus x squared. And since we are going to apply the quotient rule, we write the quotient rule, which says that dy on dx is equal to v du on dx minus u dv on dx, all divided by v squared. And this is the quotient rule. So it means that from the function we have to identify our u and v and then differentiate. When we are done, we substitute into the formula. So from the function at the numerator will be for u, so it means that u is equal to 3x, and then the function at the denominator will be that of v, which also implies v is equal to 1 plus x squared. Now after identifying them, we differentiate the functions with respect to x. Now so here, to differentiate u is equal to 3x, we have du on dx. So when differentiate 3x here, we have 3. And then we come here also and differentiate v with respect to x, which means we have dv on dx. And then when we differentiate 1 plus x squared, that gives us 2x. So once we have the functions and their differential, we substitute into the quotient rule. So here we have dy on dx to be equal to, we know v, so it says v, but v is known to be 1 plus x all squared. Sorry, that's 1 plus x squared. So you write 1 plus x squared. Now it's being multiplied by du dx, and du dx here is 3. So you multiply by 3. Minus u, but u is known to be 3x. So that is 3x being multiplied by dv dx, and dv dx here we know to be 2x. So multiplied by 2x. Now it says all divided by v squared, and v squared here is v all squared, so that gives us 1 plus x squared all squared. So once we have this, we just simplify by multiplying, and now dy dx is equal to dy on dx is equal to 3 by 1 gives us 3 plus 3 by x squared gives us 3x squared, minus, so 3x by 2x gives us 6x squared, all divided by, so here we have 1 plus x squared all squared. We continue by further simplification, and our dy dx is now equal to, so we maintain 3, and then we subtract 6x squared from 3x, that gives us minus 6, that is minus 3x squared, all divided by 1 plus x squared all squared. So further simplification also gives us dy on dx, which is equal to, we can see 3 is common here at the numerator, so we factorize 3 out, and that gives us 1 minus x squared. Now we divide by 1 plus x squared all squared, and this becomes the solution to example 1. We continue with example 2. So this is example 2, and it says that if y is equal to 1 minus x squared divided by 1 plus 3x, find dy dx. So we have our solution here, and since the two functions are being divided, we apply the quotient rule. So that is 1 minus x squared divided by 4 plus 3x. So the quotient rule says that dy on dx is equal to v du on dx minus u dv on dx, all divided by v squared. So you identify our u and v from the function, and the function at the numerator is for u, so it means u is equal to 1 minus x squared, and then that of the denominator will be for v, 4 plus 3x. So here we differentiate u with respect to x. That gives us du on dx. So when we differentiate 1 minus x squared, it gives us minus 2x. And when we differentiate v with respect to x, we have 3. So once we have the functions u and v with respect to their derivatives, we substitute into the quotient formula. So this implies dy on dx to be equal to, so it says v. Now v is known to be 4 plus 3x. We write our 4 plus 3x here, multiplied by du dx, and du dx is known to be minus 2x. So we write our minus 2x here, and then here we continue by bringing our minus sign, and it says u, but u is known to be 1 minus x squared. So we have 1 minus x squared being multiplied by dv dx, and dv dx is known to be 3. We write our 3 as such. Now we continue by dividing everything by v squared, and then we know v to be 4 plus 3x, so that gives us 4 plus 3x all squared. Now we continue by simplifying, so we can see that minus 2x multiplied 4, that gives us minus 8x, and then 3x by minus 2x gives us minus 6x squared, and then here we multiply 1 by 3, that gives us 3, and minus x squared by 3, that gives us minus 3x squared. We also continue by dividing everything by 4 plus 3x all squared. Now at this point we have our dy dx to be equal to, so we expand the numerator, that gives us minus 8x minus 6x squared, and then minus 3. So you have plus of 3x squared all divided by 4. So we have all divided by 4 plus 3x all squared. Now further simplification also gives us dy on dx to be equal to, so we can see there is minus 8x here, so you write it, and minus 6x squared plus 3x squared gives us minus of 3x squared, and then we also maintain that of minus 3. We divide everything by 4 plus 3x all squared. So you can beautifully rearrange it as, so you bring minus 3x squared first, followed by minus 8x, and then we end with 3. So we arrange it with increasing powers of x. Now we end it by dividing everything by 4 plus 3x squared. So this becomes our solution to the example above, and we end today's video here. So thanks for watching. Kindly like, comment, subscribe and share. Remember that this is BakoMaths. We are thinking beyond infinity.